Hello! Yes, and welcome to our Objective 3.5 notes on solving logarithmic equations. Objective 3.5 says I can solve logarithmic equations, and that is what we're going to do today. So if we're solving an equation for the variable in the argument of a logarithm, we need to convert the equation to exponential form. Now, in order to convert to exponential form, we must have our equation in the form log of x equals y, whatever another value may be. The key here is we have to isolate the log. We have to get the logarithm all by itself. Now remember, with logarithmic equations, we need to check our answers for extraneous solutions because of the requirements. Check our answers. There we go. For extraneous solutions because of the requirements of a logarithm. Remember, we can't have a negative argument. We have to have, it has to work out in the end. It is possible to get extraneous solutions here. So let's do some examples together. Make sure we know what we're doing, and then we'll get you working on your own. So for letter A, the natural log of x minus 4 equals 2. So looking at letter A, our logarithm is already isolated on the left side of the equation, so we're good. So we can go ahead and convert this to exponential form. So this in exponential form would be e, right, because it's natural log squared equals x minus 4. So I just need to add 4 to both sides, So we'd find x equals e squared plus 4. And to figure out what that is in my calculator, I can do second e squared and then plus 4, and 11.39 would be my answer here, 11.39. And there we go. There is the exact value, and there it is rounded to the nearest hundredth. All right, let's look at letter B here. Now notice, before we move on to letter B, I almost forgot. I need to check my answer, and that's why this rounding is so helpful. If I plug in 11.39, this would be 11.39 minus 4. That would definitely give me a positive number, so that checks out, right? I have to have a positive value in that argument. All right, let's see here. Log base 7 of x plus 2 minus 8 equals negative 4. Okay, so I got to isolate the log first, so I'm going to add 8 to both sides. So I'll have log base 7 of x plus 2 equals 4. And now that my logarithm is isolated, I can write it in exponential form. So it'd be 7 to the 4th equals x plus 2. When I subtract 2 from both sides, I can say x equals, what is 7 to the 4th power? It is 2401. And then I subtract 2, 2,399. And that would be my answer here. That is both the exact answer, and obviously we don't need to round because it's already exactly an integer, 2,399. Very cool. If I plug it in for x up here, I definitely get a positive value. It checks out. All right, let's look at letter C here. Okay, so I'm going to start, got to isolate my logarithm. I add 2 to both sides. So I have 4 natural log of x minus 9 equals 8. Divide by 4 to get the natural log all by itself. So I'll have the natural log of x minus 9 equals 2. So that means, to convert this, I'd say e squared equals x minus 9. I'd have to add 9 to both sides. So I'd say x equals e squared plus 9. Let's go ahead and figure out about what that is. So second e squared plus 9. 16.39, that equals 16.39. And if I plug that back in, 16 is obviously more than 9, so I would get a positive value there. Awesome. Let's do some with a little more operations that need to occur here. Let's look at letter D. So I'm going to start this by dividing by negative 2. When I do that, I have log base 9 of negative 5x equals 4. So this would be 9 to the 4th equals negative 5x. So I would need to divide by negative 5. Now, I do not know what 9 to the 4th is, so let's figure out what that is. 9 to the 4th is going to be a large number. divided by negative 5, I get negative 1312.2, negative 1,312.2. Now notice, if I put in a negative value for x here, it'd be a negative times a negative. That would in fact give me a positive. So that checks out. Nice. Let's look at letter E here. So I need to start by subtracting 7 from both sides. I'm going to subtract 7. When I do that, I get negative 3 natural log of x plus 5 equals negative 27. I'm going to divide by negative 3, divide by negative 3. So I'll have the natural log of x plus 5 equals 9. And here I can go ahead and say e to the 9th equals x plus 5, subtract 5, so I'll say x equals e to the 9th minus 5. That would be the exact value, right? And remember, I'm keeping this as e because e to the 9th, anything e, right, is a never-ending decimal, right? It is an irrational number. Therefore, this is the only way I can write it as an exact value. So when I plug in e to the 9th, I wonder if it'll even let me. Second, e to the 9th, and then minus 5. 8,098.08. There you go. That equals 8098.08 when I round that to the nearest 100. Very good. All right, lastly, let's look at letter F here. So I'm going to start by subtracting 10 from both. Well, 10 minus 10 is 0. Oh, this is going to be a good one. Log base 11 of 3 minus 7b equals 0. When I divide by 8, 0 divided by anything is just 0. I get log base 11 of 3 minus 7b equals 0. And I'm excited because when I convert this to an exponent, to exponential form, I'm going to have 11 to the 0 power equals 3 minus 7b. I'm not even going to need to use my calculator on this because I know anything to the 0 power is 1. So I'm going to have 1 equals 3 minus 7b. So I'm going to, let's see, subtract 3 from both sides. So I'll have negative 2 equals negative 7b. Divide by negative 7, divide by negative 7, and I find that b equals 2 over 7. Voila. And we'll call that good. We'll call that a day. All right. Hopefully we're feeling pretty confident solving logarithmic equations. If we're feeling good, go ahead and get started on those practice problems. If you want to see a few more sample problems, go ahead and check out the sample problems video for this objective. This is Mr. Carter signing off. I'll see you next time.